Okay, this is IM2, and we're going to talk about some other lines that are inside a triangle that have a point of concurrency. And last time, in the last lesson, we talked about bisectors. So this time we're going to talk about medians. And medians are where you take the midpoint, which is why we call it a median, of a side. And I've put that dot already for you. I built this ahead of time. And what you can do is you can draw a line segment from that spot to the vertex. And that is called the median. I'm going to label it so you know what I'm saying. All right, so the median is from the midpoint of the side to the vertex. So we can draw all three medians from there to there and from there to there. And as you're not shocked, they all meet in a center point, right? And that point has a specific name, so I will label it. I'm going to turn it a different color, and I'm going to label it. And we're going to label it, and it's going to be the centroid. Okay, so that is where all of the medians meet. And the centroid does not have to be in the center. Excuse me. The centroid is always in the center. I was thinking of the other one. As you can see, if I can make it an obtuse one, it's still in the center, or it's still inside the triangle. So the centroid is still inside the triangle. It does not have a circle that corresponds to it, but it does stay inside the triangle at all times. All right, I'm going to leave this on here, and we're going to actually build the other portion. And the other portion is what's called altitudes. And altitudes are where you make a 90-degree angle coming off of the side, and it goes through the vertex. It's different than the perpendicular bisector because it does not have to go through this center point. So I'm going to use my perpendicular line, and I'm going to select the side, and then we're going to go through the vertex right there. You'll notice that this is the midpoint, and this is where, if you dropped a line straight down, if you were hanging this from something and you dropped a string straight from the vertex, that's where it would hit. Same thing here. We can take this and we can run a vertex. This is the altitude. In just a second, I'll go ahead and color the altitude something a different color so that you can tell which ones they are. I mean, they're the ones that are way extended past. So I'll turn all the altitudes green so you're not distracted by the other lines. So the altitudes, and I'll go ahead and label one. Oh, I can't label it. Never mind. All right, so the altitudes, and they all meet at a center point as well. And this center point has a unique name, and that's called the orthocenter. And unlike the centroid, it doesn't have to be in the center. So we can make this, actually, here, we won't go quite that far out. We'll just move this down. If we turn this into an obtuse triangle, you see the orthocenter leaves the triangle, the centroid remains in the triangle. If we make it a 90-degree angle, it's going to land right on one of the sides, right? The right triangle will make it land right on the corner. And if we make it an acute triangle, it's going to be in the center, and it varies drastically depending on where, right? So it can be closer to one side or the other side. And we can move it all over the place. We can move these lines as well just to show that. But the centroid, again, is made up of medians, and the orthocenter is made up of altitudes.